All right, hello again. This is Jeff Scott of Blackhawk Technical College. We've been going over the book part of starting out with Java 6th edition by Tony Gaddis, which is the textbook for our 152-143 Intro to Java programming class. I first went over the PowerPoints for the first 11 chapters, and I've gone over both the book presentations for chapters 1 to 7, and for virtually all those chapters also I have written payroll programs. All right, and we're into chapter 8 right now, so before we go through that program, let's talk about the book material. You can see we'll talk about static class members, passing objects as arguments to methods, returning objects from methods, overriding the toString method, writing an equals method, methods that copy objects, aggregation, looking at the this reference variable, looking at enumerated data types, talking again about garbage collection, and talking again about CRC, or class responsibility collaboration cards. So, as we get started, the first thing that's in here, sorry, I'm back at home, so if you hear noise in the background, the washer is running. A static class member belongs to the class and not objects instantiated from the class. What the heck does that mean? Well, maybe the easiest way to show you is to go back here, not there, to go back over here, and let's see if we've got it in the driver here. Well, I know I've got it in the last chapter. So if you remember the name of this class, this was the payroll driver class, but the actual name of the class that we were working with was class payroll. And when we go back and we look at the driver for chapter 7, when we were printing out all of the final information and we wanted to print out a count of the number of employees, one way to do that was to say payroll, which is our class name, not an object name, but the name of the class dot count. What does that have to do with anything? Well, the key ingredient here is when you're working with a static program variable like count, you can use it without having to instantiate or create an object. We can give it the name of the class dot count. And if you say, I don't get it, we've been doing that for a while. Again, for example, Java has a math class. You don't have to create an instance of the math class. You can just start using it. You can say math.py, for example, or math.square root, or whatever. So as mentioned, the static member belongs to the class, not the objects instantiated from the class. So unlike instance variables, where back in chapter 6, when we did this, box.setLength, where every time we created a brand new rectangle object, each object got its own length and its own width. With static class members, there's only one that's shared among every object of the class that's created. And that's what the author is trying to say in here. So as it says, it is possible to create a field or a method that does not belong to any instance of a class. And that's a static field or a static method. When a value is stored in a static field, it's not stored in the instance of the class. That's why you don't have to create an instance of the class or an object to be able to use it. Again, if you look down at that second paragraph, when a field is declared with the keyword static, there will be only one copy of the field in memory regardless of the number of instances of the class that might exist. So they all share it. So a couple things here. Notice it says this demonstrates a static field. We've got this public countable. All right. And we've got private static instance count equals 0. And then for countable, we just add 1 to that instance count. All right, and we return it, but It says here the first thing to notice is we've got the word static in there. By placing the word static in there after the private access specifier and before the data type, we've let the system know that there will only be one of these regardless of the number of objects of the class that we create. You can see here Java automatically stores 0 in all uninitialized static member variables. Well, that's 0 in numbers. If it's a string, it'll automatically hold the empty string, and if it's a Boolean, it'll automatically hold false. So here's the demo. Int object count. So notice we create 3 objects, and that's going to make our object count be 3. All right? But notice we say object count equal object1 dot get instance count. All right? We could have said right there either object count equals object1 dot get instance count, or we could say object count equals object2 dot get instant count, or we could say object count equals object3 dot get instance count, or we could just have used the actual name of the class itself, which is countable. So the other thing there we could have done is we could have said object count equals countable dot get instance count. Regardless of which of those 4 ways we'd use, we would come back and say 3 instances of the class were created, because those are the 3 right there. That's pretty much what he explains here. When a class contains a static method, it isn't necessary for the instance of the class to be created to execute the method. Now, we're going to go over, I'm going to step out just for a second here, but then we're going to go over this program in quite a bit of depth and breadth of coverage in just a minute. All right, sorry about that. So let's go through this program right here. We've got a class that's called metric, and you'll notice the class has got inside of it a miles to kilometers method right here, and it also has a kilometer to miles method right there. All right, and hopefully you notice that both the kilometer miles and the miles to kilometers were both static. What does that mean? That means in here we're creating, all right, in this particular code that you see right here, we never have to new or actually create an existence of that metric class, but we can use its methods. Miles equal metric, so it's the name of the class, not an object, because those 2 methods were set up as static. So we can say miles equal this, and here we can say kilos equal this. All right, so again, static means one that's shared. All right, to pass an object as a method argument, you pass a reference. Okay. Remember, there are 2 ways that you can pass things. With all the Java primitive variables, you pass by value, which means a copy of the parameter is passed. But with arrays and with array lists and other types, strings, and other types of Java objects, they're passed by reference, which means an address gets passed in, which means that any change that you make to an object inside of a method, a passed in object, is a permanent change. All right, they explain that in here. I don't know if they do it better than I just did or worse than I just did, but I'll let you take a look at that yourselves. In the same way that you can pass an entire object into a method, you can return an object from a method. So you'll notice that in the example right here, Public static bank account, get account, yeah, where is it? Return new bank account and return the balance. And it says here that we're returning a bank account. And we did not create an instance prior to this of a new bank account. We didn't have to because the method itself is static. And you might find that to be a little bit confusing. Again, we'll go over it more in class. All right? A return type of bank account means that the method returns a reference to a bank account object when it terminates. Basically, it returns the address to where the bank account object lives, so to speak. And that's all explained in here on page 507. All right. By default, if you use the toString method that comes from the java.lang class, it doesn't give you very much. Normally, what you want when you use the toString method is you want to print out some information about an object. So usually what you end up doing is you end up overriding the toString method by putting in your own code so that the toString method does what you want it to do. All right, to give an example in here, I think they do at least. I'm hoping. If you don't override it, nope, they didn't show an example, I don't think. It's all gone. What's going to happen when you don't override the string method is you're going to get back something that just looks terrible. And what I mean by saying that it looks terrible is it'll have the name of the method and then it'll have some kind of a weird address, which basically is a hash of where that object lives in memory. But if you don't want that, then what you have to end up doing, and this is what they're doing here, they're overriding the string method, the toString method, to make it do what you want it to do. So as it says down below it, it says this method now creates a string which lists both the stock's trading symbol and its price per share. Well, why does that matter? Because now you get output that looks like this. It's actual viable output that you can take a look at and it would make a lot more sense. Okay? All right. It says you cannot, just like with a string, because remember strings are objects, you cannot determine whether two objects contain the same data by using the equal operator. Same kind of thing that we saw when we worked with strings. If you use the equal, what you're asking is, do these two things point? You're not asking do they have the same value, but you're asking do these two things point to the same variable? This points to that one, this points to that one. So when you do this, and you say stock company 1 equals new stock XYZ962 and stock company 2 equals new stock XYZ962, using the equal is a mistake. All that says is do they point to the same object? And they don't, so even though they hold the same information, this is what's going to end up printing. The objects are different. As it says, when you use the equal operator with reference variables, the operator compares the memory addresses. All right? Double checking to make sure that I turn the tape back on again. So, as they say down below it, because the two variables reference different objects in memory, all right, it'll say that it's false. So if you want to check two objects to see if they equal the same thing, you've got to check individually every member that's in each of the objects versus every member that's in each of the other objects. Now that may or may not make sense, so let's take a look at it here. What you have to do is you have to say is the symbol in this one equal to the symbol in this one, and is the share price in this one equal to the share price in that one? And if all those checks are true, then they are equal to one another. So that's what they show you here in listing 810. Okay? All right. It says you can simplify the process of duplicating an object by creating a class that returns a copy of the object. So in this first example here, the stock company 1 equals new stock XYZ 9.62. Stock company 2 equal company 1. Well, notice what we've done when we did this. Probably not what we wanted to have happen. It didn't make a copy. Rather, it made a copy of the address. So in other words, doing this and then doing this makes company 2 an alias for company 1. So now we can change either company 1 or company 2. Since they both point to the same thing, changing one will change the other one. They mention here down toward the bottom of the page that this type of an assignment is called a reference copy, because only the address is copied, not the actual object itself. If you want to copy the actual object itself, you must make a new object and then set the new fields to the same values of the one being copied. And I think they call that a deep copy. Or the other one I think is called, what we say, is it a shallow copy? Reference copy. Okay. I think a reference copy is also known as a shallow copy. We'll see that, if not in this chapter, we'll see that in a later chapter. So again, you'll notice we have 2, there's 1, there's another one, but we're copying the values in here. All right, it says make a reference copy. All right. Display the contents of both. Confirm that we actually have 2 objects. All right. And we do. Even though they have the same values. All right. Another way to do this is to create what are called copy constructors. This is probably, this and what we just looked at is probably the hardest stuff that we go over in the first semester. All right. So another way to create a copy of an object is to make a copy constructor, which is a constructor that accepts an object of the same class as an argument, and that creates a copy. It says here you'll find another version of the stock class. It has a copy constructor. The code that follows is the only code that has been changed. So the only thing that's shown here is the copy constructor. It says notice that the constructor accepts a stock object as an argument. It'll reference the argument or the object that was passed in as an argument, and it'll copy the values appropriately. Okay, there you go. All right, aggregation. As mentioned here, aggregation occurs when an instance of a class is a field in another class. All right, I think I gave you an example of another one before, but let's talk about this one. Let's talk about, for example, an automobile. All right, and then let's say that before we even do an automobile, I make what I call a tire class, T-I-R-E. You know, that's going to hold tires. You know, it has rims, it has sizes, and it has a bunch of other stuff to it. So I create that, and then later I create an automobile class. Well, it might very well make sense that an automobile could have as one of its element tires. So I would take that tire class and I would make that class part of my automobile class. That's aggregation. And here an instance of a class is a field in another class. Now the example that they give in here, and this takes up a lot of the rest of this chapter, says let's say that we create a class that's called course. And the core for each course, there's the name of a course, there is an instructor who teaches it, last name, first name, and office number, and there's a textbook, title, author, and publisher. All right? So, there's the associated UML. I'm not really that concerned with that. But here's our instructor class. Here's our 3 private variables, last name, first name, and office number. There's our constructor. We even have a copy constructor. We want to create another one. We've got a set, just one set. I'm not sure why they did it this way. All right, just one set, as opposed to having 3 different sets, a set last name, a set first name, and a set office, but they did it like this. All right, they've overridden the toString method to have it print all the information about an instructor. And that's it for the instructor class. Now, remember that one of the things that an instructor had, instructors have first name, last name, and office hours, but courses, not instructors, but courses also, so we've got the instructor information, but we have to create another class that's got textbook information and maybe another one for our course information. So here's the textbook class. And you'll notice that a textbook has what? A title, an author, and a publisher. All right. Again, by now at least, this should be pretty self-explanatory as far as what's going on here. In fact, this class looks almost identical to what we just had for instructor, except you're replacing first name with title, last name with author, and office number with publisher. But other than that, they look very similar to the way that the other one was set up. Override the string method, etc. So the UML is going to be almost identical. Now, it says when the instance of one class is a member of another class, we say there's a has-a relationship. We talked about is-a when we talked about inheritance, but now with aggregation, it's has-a. The course has a or has an instructor. The course has a textbook. So when you have a has a type of relationship, you've got aggregation. So when you look in here, course name, notice it's of type string, but notice the other two. So the instructor and the textbook, these 2 members of our class course are both classes on their own. And that's what we're talking about in here. So notice, course name is of type string, instructor is of type instructor, textbook is of type textbook. All right, so we're able now by doing this to be able to call those methods from those other classes. So when we look at the demo here, we're going to have something like this. Course name, all right, and we got that from the string from the course class. The instructor information, the last name first, or first name, last name, and office number, we got that from the instructor class. The textbook information, the textbook title, author, and publisher, we got that from the textbook class. All right, so when you use aggregation in here, now it's a diamond to show this. So what it says is we first create an instructor and a textbook class, and we can use those classes as fields in our course class. All right, but they mention there are potential security issues with doing this. It says when writing an aggregate class, be careful not to unintentionally create security holes. So the author says, we will focus on the 2 specific practices that can help prevent security holes. Number 1, perform deep copies when creating field objects. says when you make a copy of an aggregate object, it's important that you also make copies of the objects it references. This is a deep copy. If you don't do that, if you make a copy of the object but only make a reference copy of the objects it references, rather than a copy itself, you perform what's called a shallow copy. When a method in an aggregate class returns a reference to a field object, return a reference to the copy of the field object. So, starting on 526, the author says, let's look at this in a little bit more depth and breadth of coverage. So let's look at it. All right. It says, notice that the arguments to the constructor in lines 19 and 20 are as follows. They accept a reference to a string containing the name of the course, a reference to an instructor object, and a reference to a textbook object. It says, notice the constructor does not merely assign INSTR to the instructor field. Rather, it creates a new instructor object for the instructor field and passes that to the copy constructor. This creates a copy of the object referenced by INSTR. So it will reference the copy. So any changes you make will be being made to the copy. All right? So it says when a class has a field that is an object, it is possible that a shallow copy operation will create a security hole. And they show an example here. Again, by just saying, grab the whole thing and copy it, grab the whole thing and copy it. All right? Because as mentioned, when you do that, all you're doing then is you're passing in the addresses of the objects, not copies of the objects themselves. Then finally here on 527, return copies of field objects, not the originals. It says, notice that when the return statement uses the new keyword, passing the instructor field to the copy constructor, the object that is created is a copy of the object referenced by instructor. Avoid using null references. We talked about what a null reference is before in other classes. I think they give an example right here. What ends up happening is someplace in here, we go in and we try to print out the value of a field before the field has been set. And what's going to happen is we're going to get what's called a null pointer exception. Okay. All right, we've kind of talked about the this variable already, and I've shown you examples. And I said that when you're in doubt, and some programmers always use the word this with a dot. All right. Most of the time where that's the most important is in here. If we already had a variable, if we had two variables, one named symbol and one named share price, and we tried to pass in sim and price, it's not a problem. But if we did this, no pun intended, if we had that one, so we've got a variable called symbol and one called share price that we've defined up on top. Well, if we try to pass in variables that have the same name, if you don't say the this dot, if that was gone right there that you see in blue, if that was gone, and you said symbol equals symbol, it would take that variable there and copy it right to itself. But by saying this dot symbol equals symbol, it grabs that symbol that you pass in and it copies it to the symbol that's an instance variable that was created at the top of the program. As mentioned, as shown right here on page 532, it says you already know that a constructor is automatically called when an object is created. You also know that you cannot call a constructor explicitly, but there is an exception to that rule. You can use the this keyword to call one constructor from another constructor in the same class. and they're showing you that right there. So it says, here's one constructor that expects two arguments, a string and a double. It says, let's also suppose we want a constructor that only accepts an argument for the symbol field, that string, and that it assigns 0, 0 to the share price field. One way to do it is like this. So it grabs sim and it copies it into here. It's going to copy it into the symbol field, and since there isn't a second argument, it grabs whatever's down there, the 0.0, and it makes that the second argument. Now that's probably something you're not going to use a whole heck of a lot, and the author even gives you two rules regarding this down toward the bottom of 532. This can only be used to call a constructor from another constructor in the same class, and it must be the first statement in the constructor that's making the call. Alright, enumerated data types are data types created by the developer. So with the example we have here, enum day. Day is now a brand new data type. Its values are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. And actually what Java does is what most other programming languages do, and that is that even though the values are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, the values themselves are accessed using integers. So Sunday is 0, Monday is 1, Tuesday is 2, Wednesday is 3, Thursday is 4, Friday is 5, and Saturday is 6. So we can create a variable after we do that of type day. And then you can do something like that. As they say, we just assign day.Wednesday instead of just Wednesday because we use the fully qualified name, and you usually have to do that. Enumerated classes are typically done to be more specialized classes. So if I created a class called day, these would be the possible values. What ends up happening typically by doing this is you end up with code that is a little bit more self-documenting. And you'll see this, in just a minute, because in just a minute we're going to look at an example, not this one, but another example that uses enumerations, and you're going to see when we work with cars and you have a switch statement just how much crisper the code is, for lack of better words. So this is creating an enumeration. This is a brand new data type that's called day. Then we create workday, which is of type day, and we say that it's equal to day.Wednesday. So the only things we could put in there would be day.Sunday, day.Monday, day.Tuesday, day.Wednesday, day.Thursday, day.Friday, or day.Saturday. So as it says, this will print out Wednesday right there. So this is the other example that they have in here, which I think is a little bit better example. They've got car type. Now notice when you create that, that is an entire file right here. This is an entire file, as is this. So this is called cartype.java, and it's got a new enumeration in there that's called car type. The three types are Porsche, Ferrari, and Jaguar. And we've got another one called car color with red, black, blue, and silver. So when you look at it, we have 12 possibilities. A red Porsche, a black Porsche, a blue Porsche, or a silver Porsche. A red Ferrari, a black Ferrari, a blue Ferrari, or a silver Ferrari. A red Jaguar, a black Jaguar, a blue Jaguar, or a silver Jaguar. And where that really ends up becoming easier to read, and it's a little bit further down in here, is when you do a switch statement. Because now rather than saying case and giving it a number or something, this code ends up being much, much more self-documenting. All right? Garbage collection we've talked about before. I mentioned that The garbage collection is a process that runs under the operating system. And what it does is it goes and checks to see if you've got any objects in memory that are no longer being referenced. And if it finds ones that are not being referenced, it typically flags them, and then it comes around and checks again, and if it still isn't being referenced, it knows that it can remove that argument, or it can remove that object from memory and free up the memory. And they show an example of that in here. I'm not going to go through it any more than that. As mentioned here, if a class has a method named finalize, it's called automatically just before the class is destroyed. Not only is there a constructor for methods, there is a destructor for methods, but the destructor is not called very often because, like the finalize method, you're not sure exactly when it's going to be called. So the last thing discussed in the chapter is this CRC, class responsibility collaboration. So the idea is you start looking through your code and you try to find out in your code what goes with what. So oftentimes when you do this, you use index cards, and on the index card you start putting down the things the class must know and the things the class must do. So you end up writing things that look like this. And what it is it's a communication mechanism. So you've got the name of the class. These are typically going to be like methods, and these are the different classes that those methods are going to have to interact with. And that's pretty much it for the chapter. All right, so I'll be back to talk about the code in just a couple minutes.